Let's take a look at an example on finding several different measures of variation. So here's some data that we've got, the flight times for a random sample of flights from Las Vegas, Nevada to Newark, New Jersey on United Airlines. And these numbers, 282, 270, all the way down to 267, are given in minutes. So this flight typically lasts, it looks like, a little over 4 hours. The things that I'm going to show you how to do by hand are to find the mean absolute deviation, the population variance, the population standard deviation, the sample variance, and the sample standard deviation. So 5 things. Okay, the first thing we need to do, 6 things. I forgot I also want to find the range. Okay, so the range will be the first thing that I find. For the range, we want to find the difference between the maximum and the minimum. This is the least sensitive measure of variability, but I need to find, let's see, the maximum is 282, and the minimum time was 257. So the range is going to be the max minus the min, so that will be 282 minus 257, which is 25, and the units on that are minutes. So that's the range of that data set. The next thing that we can do is find the mean absolute deviation. To do that, we need to find the mean first to find out how far things are from the mean, how far they deviate from the mean. So the mean is the sum of all the scores, all those data values, divided by the number of data values that we've got. Well, we have 7 data values, and I'm going to add up 282 plus 270 plus 260 plus 266 plus 257 plus 260 plus 267, add all 7 of those times up, and divide by 7. When I add all those times up, I get 1,862, and that number divided by 7 is 266 minutes. That's the mean. To find the mean absolute deviation and really all of these other things, I have to find out the deviation. What is the score minus the mean? So I need to take 282 minus 266, and that gives me 16. And then 270 minus 266, and that is 4. 260 minus 266 is negative. Watch out on that negative there, negative 6. 266 minus 266 is 0. That one took the average amount of time for this sample. 257 minus 266, this is going to be a negative again, negative 9. 260 minus 266, I feel like I did that one already. And 267 minus 266 is 1. If I add up these deviations here, 16 plus 4 minus 6 plus 0 minus 9 minus 6 plus 1, the sum of these things adds to 0. And that should work. That should happen. That's kind of a check that you did everything right, because the sum of the deviations from the mean should equal 0. So that's good. To find the mean absolute deviation, I want the absolute value of these deviations. So the absolute value of the deviation. 16, 4, 6, 0, 9, 6, and 1. The mean absolute deviation, or the MAD, is the sum of the absolute deviations divided by the number of data values that we have. So if we add up these deviations here, 16 plus 4 plus 6 plus 0 plus 9 plus 6 plus 1, that should not give us 0 because all of those numbers are positive here, and we end up getting 426. So I'll take 426 divided by 7, and that is, where did I write that down? No, yuck, sorry. This is where I should edit the video. I get 42 when I add those numbers up. I was looking at the wrong column. So 42 divided by 7 is 6. So the mean absolute deviation is 6 minutes. So I found the range, I found the mean absolute deviation, and this is saying that these scores typically vary from the mean by about 6 minutes. There are more sensitive ways to do, a little more sophisticated ways to also measure variability, and those would be the population variance and population standard deviation, the sample variance and sample standard deviation. Because this was a random sample, I really should be using the sample variance and sample standard deviation, but in this video I wanted to show you how to calculate the population variance and population standard deviation. That would be useful if these data represented the entire population. So for the rest of these, we're going to, instead of using the absolute deviations, we're going to use the squared deviations. And the squared deviations, both the absolute value and the square, will turn these things positive. So these things being the deviations. 16 squared is 256, 4 squared is 16, negative 6 squared is 36, 0 squared is 0, negative 9 squared is 81, negative 6 squared 36, and 1 squared is 1. So what I do with these squared deviations to find the population variance is I will find the sum of those squared deviations and then divide by the number of things that we have. So this is where that 426 comes from that I added up earlier on my calculator. So that would be 426 divided by 7, and this number is approximately 60.86. If you wanted to put some units on here, it would be squared minutes, but that really doesn't make any sense to me, so I'm just not going to put any units on there. That's the population variance. Now the population standard deviation is going to be the square root of the population variance. So it's the square root of the sum of the squared deviations divided by the number of terms, or the square root of 426 divided by 7, which is approximately 7.8, and the units on here are minutes. This is saying that in this population, the data values that are approximately 7.8 minutes away from the average of 266, which is kind of in the same ballpark as the 6 minutes. These are different measures of variability, so I'm okay with getting slightly different numbers. It would be weird if this was 6 and this was 90. For the last two, the sample variance and sample standard deviation, very similar to the population variance and population standard deviation. So the difference is that I'm going to take the sum of the squared deviations, and instead of dividing by n, I'm going to divide by n minus 1. This is helping us kind of make this unbiased, and that's as deep as I'm going to go with this in this class. But what that does is it says we just have a sample. There might be some other values out there, and so we want to kind of make our estimate a little bit bigger. Dividing by a smaller denominator is going to make our estimate a little bit bigger, so we can have a little more confidence in that. So that's going to be 426 divided by 6, because 7 minus 1 is 6. That number is exactly 71. The units on that would be minutes squared, or squared minutes, and I'm not going to bother with that. Sample standard deviation is going to be the square root of the sample variance, which we just figured out. Sample standard deviation would be the sum of the squared deviations divided by n minus 1, or in this case, the square root of 426 divided by 6, or the square root of 71, which is going to be approximately 8.4 minutes. And that is how you can do these by hand. Of course, if you know ways or want to do things with technology, that's fine too. But these are the 6 measures of variability that we'll talk about in this class.